pilots are flying what's called a super scooper. At around $30 million, it's one of the most expensive aerial firefighting aircraft ever made.
It's literally a boat with giant wings, and it's built like a tank. It looks like no other plane in the world.
The CL-415 Enhanced Aerial Firefighter can scoop and drop 1,400 gallons of water on wildfires in a matter of minutes. Compare that to this 1970s plane, which could only drop 200 gallons of water at a time.
$30 million is very expensive for any aircraft. However, it's actually the most cost-effective aerial firefighting asset.
Super Scoopers revolutionized aerial firefighting, and Insider got an up-close look with Bridger Aerospace to see how this aircraft is tailor-made to fight fires. Airplanes have been used to fight wildfires for almost 100 years, but early attempts weren't nearly as effective.
In the 50s and 60s, almost all the aircraft used to fight fires were retired or salvaged World War II aircraft. Tanks were strapped to the middle, and they were used in a very haphazard provisional manner.
Some of these makeshift firefighting planes were only able to drop 150 to 200 gallons of water at a time.
Not really effective in today's world, but at the time it's the best they could do.
Canadair was contracted to design a plane specifically to fight fires.
So they designed the grandfather of this airplane, the CL-215, looked very similar,
which Viking Air Limited modernized in 2020, retrofitting the CL-215 with a new avionics system, turbine engines, and more.
It was taken down to its bones and created essentially a new airplane.
Weighing in at 30,000 pounds, the CL-415 EAF is 30 feet tall and has a 93-foot wingspan, just 24 feet shy of a Boeing 737's wingspan.
When you're up close to it, and you really appreciate just the massive size of it.
But despite its size, the aircraft was engineered to fly like a much smaller plane.
When you look at them, they don't necessarily look like they'd be an aerobatic or stunt plane.
We're taking a plane almost the size of a C-130. We're flying into extremely narrow canyons, very low altitude, banking high G turns at a high rate of turn. Flying an aircraft this big, that low, and that dangerous of an environment is very rare.
The Scooper is so nimble because of its flight control surfaces, or aerodynamic devices that pilots use to adjust and control the aircraft. On any plane, the main control surfaces are the ailerons, which control the plane's roll, the rudder, which controls yaw or the aircraft's direction, and elevators, which control the aircraft's pitch. And in the case of the Super Scooper, those flight control surfaces are supersized.
That's important because when you're flying slow and big, you need to have a lot of aileron area, a lot of elevator area to be able to move that aircraft as quickly as you need to at those low speeds.
That's why this rudder is 25 square feet larger than that of a Boeing 737-900, even though the Super Scooper is 10 feet shorter and half as long. This is crucial for the Scooper. It needs to slow down to 90 knots, or just over 100 miles per hour, to perform a scoop. That's almost half the aircraft's standard cruising speed.
Once you've identified your scoop site and you're coming in, you go through your pre-pickup checklist. One of those items is probes down.
Probes are down.
The way the aircraft picks up water is it does not stop or suck it up. There's no vacuum. It scoops it, and it scoops it through what you see here. 2 probes on either side of the keel of the aircraft, about the size of your hands put together. And as soon as you hit the water, they catch. You can feel that in the cockpit. You got to be ready for that catch with the yoke.
Right there, get ready to add some power. Now. Oh.
And the water begins filling almost immediately.
It takes the Scooper 12 seconds to fill its tanks with 1,400 gallons of water, during which time the pilot has to maintain the plane's speed and direction.
Once the aircraft is full and the tanks are full, you retract the probes. There is a noticeable surge in the aircraft when those probes go up, get the aircraft back up to speed, and take off.
Now 11,000 pounds heavier, the aircraft relies on its design to ascend from the surface.
If you look at the wing, you can see it has a very large curvature to it. That's called camber, which creates an enormous amount of lift.
But aerodynamics aren't the only factor involved. The plane is outfitted with turboprop engines that generate more than enough power to lift it off the surface.
They make 2,380 shaft horsepower each side.
These engines are extremely durable. You never want to hit anything with them, of course, but if it's ash or debris being pushed up through the thermals of the fire, these engines are going to chew right through that and keep running.
All that enables the scooper to ascend back up to its previous altitude in roughly 3 minutes.
Scooper 282 is inbound loaded for the drop.
So when we're lining up for a drop, the air attack will get us on target. They're in contact with the folks on the ground who are requesting the water. We're factoring in the terrain, the wind, our altitude for when we need to press the button to make the drop.
When the pilot is ready to drop the load, they'll press the water drop button.
And 3, 2, 1, drop.
Opening the drop doors on the keel and releasing 1,400 gallons of water.
Loads away.
It only takes 2 seconds for the aircraft to drop its entire load, a very short window for the pilot to work with.
There is no targeting computer. It's all by feel and by experience.
But the Super Scooper's high-lift wing and turboprop engines allow it to attack forest fires from a lower altitude and speed than other firefighting aircraft. While planes like the 747 Supertanker and DC-10 make drops from between 200 and 800 feet, the Super Scooper can do so from as low as 100 feet above a fire.
When you're fighting fire at low altitude, flying through mountains and smoke and trees, having the ability to quickly adjust to terrain variations, other aircraft in the area, or obstacles that emerge through the smoke is very important.
After performing the drop, the scooper can simply head back to the water source to pick up another load, rather than refilling on the ground.
So from drop to drop, it really depends on how close our water source is. But I've been on fires where we're dropping a load of water every 6 minutes.
The aircraft can go up to 6 hours between refuels, depending on conditions, meaning it can fight fires longer than other aircraft that need to refuel every 2 hours.
Although the sticker price on the aircraft is very expensive, it can deliver 150,000 gallons in one service day compared to a more traditional tanker that can oftentimes only do a small fraction of that. It's actually the most cost-effective aero firefighting asset.
And with a paint job like that, it can be hard to miss.
It's a very flashy paint job on these aircraft, and it's one of the questions we're asked quite often is why is it painted the way it is? The goal is to be visible in this super dense smoke. It's a very action-packed circuit when these guys are fighting the fires, and safety is the ultimate goal.
For aerial firefighters, the next game-changing innovations aren't going to come to the planes themselves.
The next ridgeline for aero firefighting is going to be data. It's going to be understanding what the fire is doing, where it's going, where it came from, and being able to share that data with as wide a population as possible. That can better inform our aerial response, better inform the ground response, and make sure that those citizens affected by the incident are given the best information possible to protect themselves, their families, and their livelihood.
In the meantime, aerial firefighting aircraft like the Super Scooper are tasked with keeping forest fires in check.
Flying this aircraft in the environment we fly it in, it's very exciting, it's very dangerous, but it's also very fun.